How to use sensors. So this is going to be a guide on how to pretty much make an autonomous program and what tools you're going to need, which is pretty much sensors, encoders, and all of that stuff. So the first type of sensors that are out there and are available are NXT sensors. So NXT sensors connect to the legacy module. They're no longer for retail. Lego actually discontinued them a while back in favor of the EV3 generation. They have nearly all the same sensors as you'd find elsewhere, such as modern robotics. And they use Lego connections instead of Tetrix, obviously. And you should only use them if you already have them and you can't or don't want to buy modern robotics sensors. These are good sensors, but they are slightly lower quality than modern robotic sensors or sensors you can get elsewhere on the internet. So the first NXT sensor that we're going to go over is the light sensor. So the light sensor has an LED on the bottom there and a sensor up top. And the sensor is to detect incoming light and its intensity. And the LED is to provide light for the sensor to sense. So what that means is that when you point it at the ground in a dark room, no matter what the surface is, it's going to be a very dark reading, and it's not going to be accurate. So the LED is there to provide a constant source of light to compare it to other values. Like if you have it on over white versus over black, it'll be able to tell the difference. So it can be put on the bottom of a robot to sense a line or a brightness change. So let's say you're going from white to black on a mat. Then this is the sensor to do that, because that'll be able to tell you, how bright the color below you is. And so that can be really useful also for following lines and autonomous. And it must be within a certain range to be reliable. This range is in like a few centimeters. So you can't just use it willy-nilly, just pointing it at random things and figuring out what they are. You have to have it within a few centimeters of the light sensor for it to be an accurate reading. And also if you have it too close, then that won't be an accurate reading. So it's a very finicky sensor. So to use this, you're going to be using the line light sensor name so to enable the LED, you can turn it on or off depending on what you want to use it for. You use the light sensor name .enable LED and then true or false. So that's a Boolean. And then to get the actual light intensity, you use light sensor name .get light detected, and that will return a double that represents how much light is being sensed by the sensor. And then there's also a version of this that returns the light detected as an integer, and this is called light detected raw. So it doesn't go through anything to turn it into a double or a more readable value. I would suggest using just get light detected because it's easier to use. And of course, light sensor name is the name given to the light sensor in hardware mapping, like we said before. So the NXT Ultrasonic Sensor is a bit of an interesting one. It's got a speaker on it for its left eye and a receiver for its right eye. The speaker is to send out sound waves, and the receiver is to take in the sound waves sent out. So these are very high frequency. Obviously, you won't hear them or anything. But basically, the way this works is it's like sonar. It sends out sound waves, and it bounces off of objects, comes back, and the receiver picks them up. And so the robot will calculate how far away something is based on how long the waves take to come back. So if it's a very short amount of time for it to come back, it'll only take, it's only a few centimeters away. But if it takes a long time to come back, it'll be maybe a couple feet away. The sensing area forms a cone around it. So if the sensor is really close to something, it'll only sense in a small area in front of it. But the further away you get, the more area it's going to sense. And as you get further and further away, it might actually start sensing the floor. So that's something to keep in mind. And it can be used to find walls or other robots in autonomous. Quick note, this can only sense 255 centimeters, so if you want to sense further than that, you're out of luck. At least for this sensor. You can find other sensors. So to get this, there's only one thing, and that's ultrasonic name.get ultrasonic level. And this will return the ultrasonic levels. This is basically the distance away from whatever it senses first. This is a double. I believe it's in centimeters, but I'm not sure. Ultrasonic name is the name given to the ultrasonic name sensor in hardware mapping. So pretty simple, but it can be very useful if you use it correctly. So touch sensor, pretty simple. It's got a button. It's a button. It can be used to stop the robot from breaking parts of itself. So it can be used as a sort of brake when you put it behind something. Like let's say you have a powerful arm. You can put the touch sensor behind that arm and then just have the program stop whenever it touches the touch sensor. So it can be very useful for that. It can also be used to detect when you hit a wall in autonomous, which is very nice. It also, if you look right there, it's got a little axle port, kind of. And so you can put things in there to make the sensing area larger, so it doesn't just have to hit that tiny little button. You can put like a plate on it, which can be very useful. So NXT Touch Sensor, pretty basic. It's got touchname.isPressed, returns a Boolean, and it's true if the button is pressed, false if it is not. So it's pretty simple. So modern robotics sensors. These are the new ones that came out with the modules last summer. Now there are more than what I'm showing you, but the ones that I'm not showing you don't have Android support yet, at least last time I checked. So there are range sensors and there are other sensors, but I won't be showing them because there's actually not anything you can do with them yet. So they connect to the device interface module, and so each of them, depending on their use, plugs into a different port. So one of them might plug into an I2C, another one might plug into an analog or a digital. So you just kind of have to look at the package and see what it says. It's the new generation, and you should use them if you have the device interface module or if their abilities aren't in NXT. So these are really good sensors, but you're not going to be able to carry them over from past years or from NXT years. So the way that the color sensor works is pretty similar to how the light sensor works. It's got an LED to project light and a sensor. So the sensor is to detect incoming light. The LED is to provide light for the sensor to sense. And it can be put on the bottom of a robot to sense a line or a color change. So not just a brightness change because this is a color sensor. And it can be put on the side of a robot to sense the colors of a beacon. Now, this one is important because it's actually been revealed that there will be beacons in next year's challenge. And so if you learn how to use this well, this will be a very important tool in the upcoming season. So the modern robotic color sensor has quite a few methods you can use, but they all return the same types of things. It's nothing drastically different. So alpha is the amount of light detected as an integer. This is pretty much just get light detected like the light sensor. It's how bright whatever it's sensing is. Then there's ARGB, which will give you the hue, which is kind of like, it'll be a number between, I think, 0 and 255, and that will describe the hue of what you're sensing. I suggest not using that because it's not always completely accurate. I would rather suggest using one of these three. There's blue, green, and red. And these are the values of each of those colors that the sensor is sensing. So a way to explain this is in elementary school or whenever you learned that, red, green, and blue can pretty much make any color. And this sensor senses how much of that color is in whatever it's sensing. It's like a brown would be kind of a bit of everything, a black would be nothing, and so on and so forth. So those can be really useful for beacons because you can just get the red value or the blue value, and that'll tell you exactly, how much it is, and you can just take the highest value. Then there is, just like the light sensor, there's enable LED, which will just take a Boolean, and it will turn on or off the LED light. And then, of course, color sensor name is the name given to the color sensor in hardware mapping. Next one is a touch sensor. Now, this is a little more complicated, or not even complicated. It's just a little better than the NXT one. It's a button. It can be used to stop the robot from breaking parts of itself, and it can be used to detect when you hit a wall. I'm sure there are other uses for it, but I'm sure I haven't thought of them. So there's button. The difference between this, one of the biggest differences between this and the NXT one is that you'll notice that the button is just a tiny little red thing. You can't really easily attach anything to that button. So what you're going to have to do is mount something in front of it that will run into the button if you want to make the area bigger. So it can be kind of annoying. I've heard of teams taking it apart and replacing that little red thing with a 3D printed button that's got a larger pad, but I wouldn't suggest it. So it's got touch sensor dot is pressed, so it'll return true if the touch sensor is being pressed. And then it's also got get value. So this will tell you how much force is being applied to the touch sensor. So if you push on it a little bit, it will return a smaller value than 1. It's 0 to 1, and so 0 would be not pressed, 1 is fully pressed, and anything in between is kind of like eh. So you can tell how much force is being applied to the touch sensor, and that's returned in a double, as I said. And then touch sensor name is given to the touch sensor in hardware mapping. So optical distance sensor. This one's an interesting one. So it's not directly an optical distance sensor. It doesn't directly sense distance. What it does is it pulses light. Oh, what is happening? It pulses light to sense reflected light strength. And what this can do is it will vary depending on the sensed material and the distance from said material. So you can kind of see it as a longer range light sensor. And what this can do is it can sense velocity in one direction. So let's say you point it at a wall or a wall of white or something. You can move away from the wall, and slowly the light intensity will drop down because you're getting further away from it. That being said, of course, if the material changes, that can give you a different value, and so it's very finicky. I would suggest finding maybe an Adafruit rangefinder or something of that sort, because even though it is technically used for distance sensing, it's not the most reliable thing you'll find. So to use it, you have get light detected, which will return the amount of light it's sensing. It's a double, and then it'll get light detected raw. It's the optical distance sensor name and hardware mapping. And so in the Java doc, it actually says that it has an enable LED feature, but it actually doesn't work because the way that this sensor works is by the LED pulsing light. And so if you turn off the LED, it doesn't work. And so if you try and turn off the LED, it won't do anything. So just something to keep in mind, don't try and do that. So Modern Robotics IR seeker sensor. So it uses 2 IR sensors to calculate the angle and position of an IR beacon. Now the IR beacon is something that sends off IR infrared waves in any direction, either 600 hertz or 1200 hertz, depending on the frequency. And this is a very situational sensor. Like last year, there weren't any IR beacons around, and so we weren't able to use this type of thing. However, in previous years, there have always been beacons next to important game elements so that you could find them in autonomous. So pretty much you're only going to use this if FTC decides to use IR beacons next year. So it can sense frequencies of, what are you doing, 600 or 1200 hertz, and it can be used to follow or find a beacon on the field. So you get a lot of different methods and values from this guy. It has get angle, which estimates the angle in which the signal is coming from. So it'll take the 2 sensors, do some math, and give you an angle. I think it has a range of 270 degrees in front of it. So if you're in the 90 degrees behind it, it won't find it. And so it'll just give you a reading, 90 degrees to the left or 20 degrees to the right. And so you can follow the beacon like that. Next one is get strength, which returns this strength from your position. It'll get stronger as you get closer and weaker as you get further away. This can be used to tell how far away you are from it. Note the beacons, at least that I've seen thus far, their signal strength will vary depending on how strong the battery is. So if the battery's been in there for longer, it won't be as strong. So you won't be able to get exact values of like, oh, it's this strength, it's exactly 2 feet away. It can more be used as a reference of, oh, I'm closer to it now. But since it varies so much due to batteries, you can't actually use it for specific distances. So the next one is set mode. So it sets the device mode. I doubt you'll use this. There are different modes it can have. Can't remember them right now, but you can use that to change the modes. You can look at it on the Java doc if you want to. So yeah, and then it's got, these two go together. So there's secret name dot signal detected. So this will return a Boolean if an IRC signal is detected. Now it only counts as detected if it's above a set threshold. So this threshold can be like 50 or 25 or whatever, and you set this threshold with set signal detected threshold as a double. So it will set the minimum threshold for a signal to be considered. So the whole point behind this is rather than saying if get strength is greater than so-and-so, you can just set a threshold for it and just be like, okay, the threshold is 25, and then just put this in as a much easier conditional to just write down all the time. So it just kind of makes it easier as you're coding. So, and of course, seeker name is the name given to the IR seeker in hardware mapping. So, next one is the compass sensor. This is an interesting one. So it measures your magnetic heading, magnetic field strength, acceleration, and tilt. The programming is still in development. All these are in the sensor. All these abilities are possible. However, the team who is creating the SDK hasn't finished development for all the methods yet, so you will only be able to access a few of these. Hopefully in the future they will come out with more, but at this point you can only use a few. It can be used as a gyro in the future, like I said, or to track other robots. I'll tell you why in a second. So since it's a compass sensor, it's kind of like a compass in the general sense that, you know, it finds north and stuff like that. However, since when motors run, they create their own magnetic field, this compass sensor can be put off by that and be attracted more to that rather than the actual north. Now you can calibrate this within your own robot to ignore your own motors. However, you cannot ignore other robots' motors, if that makes sense. This can be a good thing or a bad thing. If you're trying to use it as a gyro, it can be a bad thing because it will put off your gyro and your robot will think it's more to the right or to the left than it actually is based on another robot. However, you can also use this put off as a way to avoid other robots. Like if you realize that you're standing still or supposed to be going straight and your compass sensor senses, oh, it's now off to the left a bit, you're going to realize that there's a motor in another, or a robot in another direction, and you might be able to program your robot to avoid it. So I wouldn't suggest using this as a gyro in competition, but rather as a possibility for offensive robot detection. I haven't tested this myself. I've only read about this. I don't know if it actually fully works or is reliable, but maybe something to test out. And as I said, there's not a whole ton for this guy. You can only check if the calibration has failed. You can get a direction, so in degrees, pretty much like north, south, east, west, that type of thing. And then it sets the mode to either calibration or measurement. So at the beginning, you can calibrate your sensor. So you'd set the mode to calibration mode, and then you would check if it failed. If it did, you keep it on calibration mode. And then you would set it to measurement mode to get the direction. It's a little bit of a strange system. Like I said, it's still in development. So I would say keep an eye on it every time they release a new SDK. Just check the compass sensor, see if anything new has been put out for it. Hopefully it'll be soon, maybe before the new season starts. So yeah, just keep an eye on it. Like I said, more still in development, and beta versions can be found on the Modern Robotics website. However, they're volatile and they can break your program because they're still in beta. So If you really want to test it out, you can, but it's up to you. So now this is, in my opinion, one of the two most important sensors you will have. And this is the integrated gyro. This will give you the rate of rotation for the X, Y, and Z axes, as well as heading information from the Z axis. So what this will allow you to do is tell what your heading is on your robot, and you can use it for very accurate movement on the field. So normally, when you're on the field and you're moving forward, your robot doesn't necessarily move forward. You can have a little bit more slip on one side. One of your motors doesn't go as quickly. You're naturally going to drift to one direction. But with this integrated gyro, you can use the heading information to tell if you're drifting off to the side, and then you can correct your movement so that you never go off of a straight line. While it senses on all three axes, it senses the rate of rotation. It can only be used to make one heading on the Z-axis. So that is pretty much on the flat plane here. So pretty much turning right, turning left if you mount it flat on your robot. So yeah, that's an interesting thing. It's got a lot of methods for you to use. So it's got a gyro name.calibrate. So this will calibrate the gyro and make sure that it's ready to be used, and will make sure everything's calibrated correctly for use. You should do this at the beginning of every program that you have, just to make sure that it will work well. Then gyro name.getHeading will return the integrated Z-axis as a Cartesian heading. So this is a 0 to 360 degree heading. And so like, let's say you calibrate your, you calibrate your gyro sensor facing this way, and then you turn this way. It'll be, okay, you are at 45 degrees since you last calibrated, okay? And so that is the most important one right there, get heading and get calibrate. Get rotation will return the rotation of this sensor. It'll return as a double. Oh, I forgot to say, the get heading returns as an integer. The is calibrating can be useful to check if a robot is done calibrating, because it can take varied amounts of time to calibrate. You can't just wait for a certain amount of time. So you can use this to check if your gyro is done calibrating. So basically, you can calibrate it and then wait for it to finish calibrating before you move on to the next step. So the raw X, raw Y, and raw Z are basically all the same. It will return the raw X, Y, and Z values, which are the rates of rotation. Reset Z-axis integrator will set the integrated Z-axis to 0. So this is kind of like how it works with the calibrate. So let's say you're facing this way when you calibrate, and then you turn this way, you're at 315 degrees. And then you can reset your axis, or your Z-axis, and then all of a sudden this direction will become 0. So this can be very useful at the beginning of turn methods, and it saves you a lot of math in the process. And then gyro name is, what are you doing? What are you doing? Gyro name is the name given to the gyro sensor and hardware mapping. And an interesting thing, on the Modern Robotics website on their gyro page, so you can just type in integrated gyro modern robotics, Team 9804 Bomb Squad made a guide to how to steer with this sensor. It has a whole ton of really awesome stuff. It goes much more in depth than I could ever go in this talk. So if you're interested in that, I would highly suggest checking it out. Like I said, the link is on their gyro page on the Modern Robotics website. It's a PDF, so I couldn't pull it and just put it on here. One last thing, calibrate, you can put it anywhere, but I would suggest putting it in the initialize, because then that'll get it done before the match actually starts, and you won't waste any time. So, motor encoder. This is the second super important sensor you've got. So it will give you a reading of how far your motors have moved. Oh, sorry about the picture. I had a picture, but it disappeared off of my computer. So, I don't know. Tetrix motors have to have the encoder installed, and AndyMark motors have to have the encoder built in. So there are two types of motors, since I don't have pictures for some reason. There are Tetrix motors, which are an older version, came out a long time ago. They come with the Tetrix kit. and they don't have an encoder built in, and so you have to buy one and install it. It'll work the same way, but you just have to buy it and put it on there before you can use it. Anti-mark motors have to have the encoder, they have the encoder built in. So as soon as you buy an anti-mark motor, well, whether it's the 40-to-1 or the 60-to-1, it will work right as soon as you pull it out of the bag, and it will have an encoder in it, which is really, really nice and useful. So these connect to the corresponding motor controller. So they have a special wire, it's a 4-pin wire, that will connect directly into the motor controller, and you have to make sure that it's connected into the right port, or else it will think that you have connected, or it will think that the right motor encoder is sensing for the left motor encoder. It doesn't know that type of thing, so you have to make sure that it's plugged into the right one. So, motor encoder, it gives you these, okay, so it gives you one value, and it's motor name dot get current position. So you don't have to make it its own thing. It all just is with the actual motor itself. So you use the motor name that you put in the hardware mapping, and you say dot get current position, and it returns the current encoder value. So the way the encoders work is it's not based on rotation, but rather in encoder points. You can imagine like lots of little ticks on the axle, and it counts every time a tick goes past. I'm not sure how many ticks are in a rotation, but I'm sure it's somewhere on the internet. So it's something to keep in mind. It'll return an integer, and this value cannot be reset. You cannot simply say, okay, now that I'm done with this movement, I'm just going to reset it. It's going to count up the entire time the program is running. So you have to keep that in mind. What you can do if you want to count the specific amount of rotations in one movement is you can store a variable at the beginning of a movement, storing the amount of encoder points at that time, and then later on, to find the specific amount that you moved thus far, you can subtract the variable that you stored at the beginning from the current variable, which will give you however many you have at that point. So it's just something to keep in mind. You used to be able to reset it in Robot C. You can't anymore. I'm hoping they add that at some point because that'd be really, really nice. But yeah, so these are incredibly important because you can use these to tell how far you've gone, and they're very reliable with how many motor encoder points it takes. The only thing that can possibly put you off is tread, like how much traction you're getting. So if you have really strong treads on one side and kind of thinner treads on another, it might slip less than another side. But generally, these are incredibly on point and will rarely ever let you down. So if you're looking for something to keep you on point for your autonomous, I suggest these.